In today's video, we'll be solving the leetcode problem number 1 to 4, which is binary tree maximum path sum. Yeah, it's a hard problem, but to be honest, very honest, it is very easy question. It is very fundamental question to be honest, and I think the last one was still quite difficult, but this is really easy. First, I'll explain you the question, then we'll move on to the code. Okay? Yeah. So yeah, basically the question is asking, yeah. So the question is asking the maximum path. Okay, the maximum path. Basically the maximum path sum. So maximum path sum here. What is the maximum path sum? If I ask you what is the maximum path sum? First of all, the path. This is the path. This whole triangle, this subtree, this is the path. And for this, the maximum path sum is 5. How? 1 plus 2 plus 3, which is equals to 5. Okay. Oh, I'm so sorry, guys. Please forgive me. Yeah, it's 6. Now coming on to this example, let me explain you. What will the maximum path sum? So as you can see from this diagram, the maximum path sum here it is minus 10. Yeah, here it is minus 10. But we don't have to take someone which is minus 10. Okay, we don't want any node which is minus, which is negative, which is less than 0. Instead, what we'll do, we'll take this as 0. Okay, now, and one more thing, if this is minus, then we'll probably go to the next node, because in sum, this thing, the negative number is actually decreasing your maximum path sum. Okay, now here we go left, now we go right. Now in left we see where is the tree. There is only one node, and the maximum path sum here, the sum is 9. But when we go to the right, we go to the left, we go to the right. And when we go to the left and when we go to the right, we see what is the maximum path sum. First we add the left term, left child, which is 15, then right, which is 7, and then we'll add the node itself. Okay, so what is this? 15, 22, and 42. Is this the question? Right? We'll just confirm it. Here it's 6, here it must be 42. Yes. So I hope you are clear with the question, what the question is actually asking. So let's get to the solution. Yeah, first self dot max. We'll take a max sum which is very less. We'll take float minus infinite. Okay, yeah. Then we'll do DFS. We'll write a function for DFS. DFS node. If not node, then return 0. Now what we'll do is we'll define left underscore gain, which is equals to max of DFS. We'll compare the left gain and the right gain with whom? With 0. With the first, we'll compare it with the left itself, that if we are comparing the left gain, like we are in minus 10. Now we'll compare it with now before moving to the left, we'll check that is this the node less than 0. Is it less than 0? If it's less than 0, we'll take it as 0. Okay, so we are comparing here. We'll take the max of it. Now we'll same go to the right. We'll check the right gain, which is max. Then DFS will go to the right, node dot right, comma 0. Now we'll do path underscore gain, path gain. Now path gain is the subtree, basically the triangle which is made. Okay, so we'll add node dot value, plus left underscore gain plus right underscore gain. Now we'll update the self dot max underscore sum, which is equal to max of self dot max underscore sum, comma, we'll compare it with the path gain. Now what we'll do, yeah, so now first we'll call dfs root, will call the function and will return self dot max underscore sum. Now a very important step which I forgot basically is, for will as we are going down, okay, as we are going down to the tree, we'll also, oh, basically from in recursive approach, we don't have the value, we don't have the maximum path sum for the upper trees, for the upper level. Basically when I'm at the child node, I'm comparing, I'm if I'm at 15 or 7, okay, now the sum is 22. Okay, now the sum is 22, but we also have to add the 20, which is 42, and before going to the 42 we'll also check the parent node of 20. In this case it's minus 10, but what if it was 100? Okay, then we would have taken the other subtree. Okay, so basically we'll return node value plus max of left underscore gain, comma, right underscore gain. Yeah, so basically this, what this means, first let me check if there is any mistake in it. Yeah, so what we'll check, first of all we'll check this thing. I'm sure you might be confused here, but this is very simple. This is basically, we are checking the max of left and right. We are checking the left gain, where to go, whether to go to the left or to the right. We compare it by taking the max and the adding the value to check which path do I need. Okay, for example, in this subtree in minus 10 920, we check the max of left gain and right gain. Left gain is 9, right gain is 20, so we go to the 20, then we return. Now coming down, we'll add the value of the node 20 plus 15 plus 7, then we go. Okay, I hope I'm clear, and thank you so much guys.